Hello everyone, this is Mr. Molo for lesson 6.2, radicals and rational exponents. Okay, so radicals is kind of a fancy word just for these square roots, and you'll kind of see today that we're not just going to do square roots, we're going to do something called cube roots and quad roots and quint roots and all those other roots that just aren't squared roots. So if you see this symbol, we should be used to that. That means it is a square root symbol. But then there might be something that has like a little 3, that's a cube root symbol, and a quad root symbol, and a quint root symbol, and so on and so on. So they all pretty much look the same, except we got to pay attention to that little number there in the top left corner to see what it is. And it kind of means the exact opposite of what a cube is and what a quad is, or something to the 4th power, or 5th power, or 6th power. Kind of like squares and square roots are opposite. 2 squared is 4. The square root of 4 is 2. 3 squared is 9. The square root of 9 is 3. So they're opposites. And it's the same thing with all the other ones. So 2 to the 3rd power means 2 times 2 times 2. So that's 8. So 2 cubed is 8. And it's the same thing. So the cube root of 8, that means what number times itself 3 times gives you 8. And the answer is 2, because 2 times 2 times 2 gives you 8. Okay, so let's look at some examples of cube roots here. So first let me write them out so that you get used to seeing. So the cube root of 27. So what number times itself 3 times, because these are all cube roots, gives us 27. And the answer there would be 3. 3 times 3 is 9, times 3 again is 27. So the cube root of 27 is 3. Same thing here. The cube root of 125 is 5. 5 times 5 is 25. 25 times 5 is 125. All right, now we get into a big one where we can't do this in our heads anymore. So let me show you where this is on the calculator. So we have the cube root of 3,375. So if you look on a calculator right here, we can press this math button. And it already has a cube root option right there at number 4. And we just put in our 3,375. And it'll tell us it's 15. So we can go back. 15 times 15 is 225. And then I assume 225 times 15 again is 3,375. Okay. Here we get into a decimal. So the cube root of 3.375. Well, if the cube root of 3,375 is 15, well, then the cube root of this must be 1.5. Okay. E has the cube root of 1, and that one's still going to be 1. 1 times 1 times 1 is still 1. Okay, and then we get into a fraction one, which people usually think is harder, but not really. We're just going to take the cube root of each of those. So the cube root of 125, which we figured out in letter B, is 5. And the cube root of 8, which we figured out in the first example, is 2. So the cube root of 125 over 8 is just 5 over 2. Okay, and then we got some problems over here that are going to go over the, oops, down here. So n roots. So this is something that might be like squared or cubed or quad root. So nth root means that whatever this number is up here is the nth root. So this means it's asking for the square root of 64. So the square root of 64 is 8. And usually when we write square root, we don't put that number there. So same thing in big ideas. If you're putting that into big ideas, don't put a little 2 up there. Make sure that you just leave it as a square root. But if you are doing a cube root as your answer, make sure you do put a little 3 up there or a little 4. Otherwise it might get marked wrong. Okay, so here we have the cube root of 27. So that means what number times itself 3 times gives us 27. And the answer there is 3. Here we have the 4th root of 256. So what number times itself 4 times gives me 256. And this one we're going to do is 4. And then we have the quint root of 243. So that means what number times itself 5 times gives me 243. And the answer for that is going to be 5. Then we have the 8th root of 256. So what number times itself 8 times gives me 256. The answer for that is 2. And then we have the quad root of 10,000. So what number times itself 4 times? Gives me 10,000, and the answer for that is 10. And then I should go back and talk about some of these might have 2 answers. And I'll kind of write which ones have 2 answers and see if we can figure out while I'm writing it down. So I'm going to write this plus or minus symbol next to some of these, and that means the answer could be positive 8 or negative 8. And I'm going to do it also for this one. So the answer could be positive 4 or negative 4. I'm not going to do it for 2 or 4. I'm going to do it for number 5, though. So the answer for that one could be positive 2 or negative 2. And the answer for 10 could be the answer for 6 could be positive 10 or negative 10. So maybe you might have figured out by now, since all of these are even numbers, the answer could be positive or negative, because positive 8 times positive 8 gives us 64, and negative 8 times negative 8 gives us 64. Same thing with number 3. I could have positive 4 times positive 4 times positive 4 times positive 4 to give me 256, or I could have negative 4 times negative 4 times negative 4 times negative 4 to give me 256. And the reason it works for those 4 is because they're all an even amount of numbers. So remember, if you have 0 negatives or 2 negatives or 4 negatives or 6 or any other even number of negatives, it's going to be a positive answer. But if I have a negative 3 times a negative 3 times a negative 3, well, that gives me negative 27, not positive 27. So for ones that are odd, like 3 and 5 or 7 or anything like that, it's going to be just one answer, just regular positive 3, because you can't have negatives there. Okay, 7 through 12, they gave us the ones here, so we don't have to figure out how to write it. And so I'm going to show you on a calculator how to do number 7. So this is one where I'm going to put in a 4 because it says quad root. I'm going to hit that math button, and I'm going to slide down to number 5 this time. That little X means I get to put in whatever it is. So if it's 4th root or 5th root or 6th root, I put in that number, and now it already has that little 4 up there. And the calculator's going to tell me the quad root of 625 is 5. And so that means 5 times 5 times 5 times 5 is 625. Okay, same thing here. So the cube root of negative 512, since it's negative 512, I know it has to be a negative 8. Negative 8 times negative 8 is a positive 64, but then a positive 64 times a negative 8 is negative 512 again. And then the cube root of negative 216, kind of the same thing, is negative 6. Negative 6 times negative 6 is 36. But then you do another times negative 6, you get negative 216. Here we have negative 3. And then we get into one of these funky looking ones where it's 729 to the 1/6 power. Okay, so we're going to learn how to rewrite these on the next page. So I'm just going to kind of show you how to rewrite it now. So this is really asking, what's the 6th root of 729? And so let's put that in the calculator because I don't know what the 6th root of 729 is. So the 6th root of 729 is 3. So that means 3 times 3 times 3 times 3 times 3 times 3 times 3. I think that was 6 times. Gives us 729. And then same thing on 12. So now we're looking for the square root of negative 81. And you might be wondering where that 1 goes in both of these. It's really to the first power out here, and you'll see more examples over there. So let's put this one in the calculator, because some of you might be screaming, Mr. Molo, it's 9. It's 9. But let's see, the square root button is just right here of negative 81. Now it says error, okay? And the error is because it's not possible, because you can't have the square root of a negative number, okay? So not possible, non-real number. Because if you do 9, well, 9 times 9 is positive 81. And if you do negative 9 times negative 9 is still positive 81. So it's not possible for you to multiply two numbers and get yourself a negative answer. That's not going to happen. Okay. So as I was saying on those last two, on 11 and 12, some of these are going to be like 13 through 15 and 16 through 18. They're really just going to ask you to rewrite them. So no math required on stuff like that when they ask you to rewrite the expression and to rewrite the expression. So if you rewrite it in rational exponent form or rewrite it in radical form, I'll kind of give you a cheat sheet up here. So the outside number, and by outside number, I mean like 3, 2, 7. The outside number turns into my numerator. And then my inside number, and by inside number for this one, I mean like 5, 3, 4, that turns into my denominator. Okay, so in case we ever want to rewrite it in a different form, either in rational exponent form or radical form, that's how we do it. Okay, not any like adding, subtracting, or anything like that required, but we just need to know where all those numbers go. Okay, so we're going to rewrite this as 4, and like I said, the outside number turns into my numerator, and my inside number turns into the denominator. So another way to write the quint root of 4 to the third power is just 4 to the 3/5 power. And both of those will give you the same answer. So I'll kind of show you that. So we have 4 raised to the 3/5 power is 2.297 blah, 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 blah. Or I could put the quint root of 5, I'm sorry, quint root of 4, raised to the third power, and we get the same answer, 2.2979671. So it's just two different ways of rewriting the same thing. So sometimes you'll see it'll be easier to write it like this, and you'll see why later in a different section about why we're redoing this. Okay, same thing on 14. So -8, the outside number is the numerator, so 2. The inside number is my denominator, so -8 to the 2/3 power. Same thing on 15. So 7 is my numerator, and 4 is my denominator. So you're just going to write those in. If they say rational exponent form, it should be with an exponent. Or here, if it says radical form, that means you're writing it exactly how it looks on 13, 14, and 15. So kind of the same thing. So 2 is my numerator now. That's going to go outside the square root symbol. 5 is my denominator. That's going to go inside that square root symbol. So another way to say -3 to the 2/5 power is the quint root of -3 squared. Okay, same thing for number 6. I'm going to put that 2 right there. So the square root of 6 to the third power. Same thing here. I'm going to say the quad root of 12 to the third power. So just rewriting it. As long as you remember these rules or write this down, that the outside number is the numerator and the inside number is the denominator, you should be good to go there. Okay, and then these last couple are just calculator problems. I just want to show you how to do a couple of them and then kind of show you why you might get some weird answers. So I have, and I can kind of show you how we can kind of do this in our heads for some of these. So 32 to the 2/5 power, I can't do that in my head. I don't know what that is. But I do kind of know the quint root of 32 is 2. 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So, and that's to the second power, not to the fourth power. And then, so the quint root of that is 2. So the quint root of 32 is 2. And then I end up with 2 squared. So my answer is going to be 4. Or you can just plug that into your calculator and forget all of this, what Mr. Molo just said. Okay, but the reason I want to rewrite these is because of problems like number 20. So number 20, if we rewrite it, it ends up looking like this. The square root of -64 cubed. Well, kind of like how we talked about it on the last page, the square root of -64 doesn't exist because there's no way I can get two numbers to multiply to -64. That's not going to happen. 8 times 8 is 64. -8 times -8 is 64. There's no way you're going to get -64. So this is another one that's not real number. Okay. 21 is another one that we can maybe figure out. So the cube root of 343 squared. So the cube root of 343, 7 times 7 is 49. 49 times 7 is 343. So it's really asking what 7 squared is, and that's 49. And then if you do the other ones in a calculator, this one's 128, this one's -243, and this one again gives you that non-real number because you can't take the cube root, or I'm sorry, the quad root of -625. That's not going to happen. You can get +625, but you can't get -625 for that one.